Okay, so good afternoon, and I'm Luca Dini presenting from Innoradiant. This work is a joint work of me and Paolo Curtoni. So I'm very grateful to Diego for having presented the context of the experiment, because I didn't prepare it. So thank you very much. And I'm going straight to where our motivation for participating in these experiments. And the first one was that we wanted to experiment a new playground of using some our experience we had on the COVID-19 related knowledge, in particular platform which is conceived for exploring the literature about COVID-19. So not really the same domain, but partly yes. The second one was the will of gaining information on usages in the COVID-19 period. This is actually a commercial request, in the sense that almost every company in the retail and manufacturing sector is, and not only, is in this period asking what are the difference of consumers behavior from the previous from the period previous to COVID-19 and the COVID-19 period. So it was there was also kind of interest in application interest. So we followed two approaches. The first one was to, as we have some focus on behavior, as I just said. The first one was to have an accurate grammar-based identification of behaviors associated to the pandemic. So this was, as we will see, was inspired by the first of our experiment, the one on literature. It is based on dependency parsing and semantic rules, and it was supposed to provide a high precision and low recall. Then the second one is more coherent with the task, because it tries to identify most of the candidate named entities, and this one is based on an existing named identity extraction system. It applies a semi-supervised filtering approach, not very different from the one that Diego exposed, and also a classification approach. So now let's go to the details. For the first approach, the input is represented as a set of triples in the RDF sense, which encode all relations in terms of subject, predicate, and object, which are detected in the corpus. These triples are obtained in two steps. The first one is the application of a semantic-oriented dependency parser, namely the Stanford one, coupled with a set of manually encoded rules, which perform standard, let's say, semantic simplifications. There are many of these rules, and they are of the kind that we all know, like featurization of negations and preposition, undoing a passive sentences, trying to handle modality, and so on and so on. So we had this set of triples as an input, and then the output was produced by a second module which contains manually written rules, which basically perform a kind of graph labeling, because all sentences are transformed into a graph where node identity is characterized either by lemmas, so string equality of lemmas, or by Wikidata ID if if some part of the sentence have been recognized by a name identity extraction system as being a concept in Wikidata. Rules are quite simple. So they have an ID which will determine the category, the broad category to be assigned, and then they can have specification for subjects, predicate, or objects. And these are a set of possible candidates for assigning the target level. We also tried to enhance graph matching with word-to-vector matching. Very simply, we, for each one of this set, for instance, the object set of the second rule, we simply perform the average of the vector associated with words, and then we compute the cosine distance with targets, and we try matching with different thresholds in order to have a higher recall. Unfortunately, without a gold standard, it's very different to set the threshold level. So at the end, in the submission, we keep the version with string identity matching rather than fuzzy matching. So results are so far extremely deceptive, as on this class we had a precision of only 0.35. We tried to identify which are the reason. I think the most one of the major reasons is that we perform the dependency parsing, and for many texts we could not obtain a reasonable representation, in most cases because of formatting problems which were derived probably from PDF conversion. Okay, the second reason was that, and I will come back on this topic, that there was the assumption that the corpus contained a kind of emotional behavior, that is subjective reactions to the pandemic, which is maybe the case, but it's not something that we noticed, at least at the first level scrutiny. We have the suspect that in all these sometimes we missed offsets. These must be seen for the next round, but there are signals that in certain specific situation offsets are completely screwed out. And well, finally, there is surely the usual problem of rules written as there was no gold standard, just on the basis of a human introspection. And we all know that this is likely to generate modules that are not extremely effective on big corpora. So So far for the first approach. The second one had as, let's say, main point the one of using an existing medical named extraction system, namely Apache CTX. We used it in its default configuration. We didn't perform retraining. Only we allowed access to the UMLS terminology service because it is a service that it's updated, so it was likely that more recent medical terms were present. CTX has been conceived for analyzing clinical reports. That is text where medical named entities are very dense, very frequent, which was not necessarily the case in our corpus. As the result, you will have a lot of common terms which are flagged as named entities in the medical domain. So basically, the problem was one, to reduce this overgeneration of CTX, and second, as it was the goal of the task also, introduce all terms which are part of a common language of talking of medical fact, which were not present, which are not recognized anyway in CTX. So to face this problem, we adopted three techniques: sentence classification, terminology-based filtering, and seeded expansion. So the point was for sentence classification, we had a strong feeling that the same parameters for selecting named entities, for instance, the confidence threshold or the probability, were not the same, should not have been the same when accounting for purely medical text, and there are in the corpus, and non-medical text, really news, standard news, or any other kind of text. So the idea was to keep certain confidence in CTX when dealing with sentences which are typically medical, and to lower this confidence, or even to exclude CTX judgment when the sentence is tagged as non-medical. So we used a very simple approach. We created our corpus from the multilingual search track using uPressCorner and uRelex, a part of them as a training set for the non-medical category, and Medisys for the medical category. Then we trained a simple BERT classifier. The model was BERT-based cased to make the difference between medical and non-medical. And then we adjusted the probability of the acceptance of CTX predictions on the basis of the type of sentence that it was analyzed. A further refinement was made by using a terminology extraction system. The selected system was term suite, and it was run on the whole train corpus. So the system identified a set of terminology candidates. Actually, it doesn't recognize only only terms, but I would say any valid noun phrase which has the tendency to occur in the corpus with frequency higher than in normal language, and performing a set of, let's say, generalization for terms variant. Thanks to these resources, basically we filter out she takes predictions which were not appearing in the terminology. Here as well, we tried different threshold. Then, as I said, there was the problem of increasing the recall, especially for behavior-based named entities, and we use it in this sense a seeded approach, in the sense that we manually selected for each category the 10 best matching terminology items which could be associated to that category, where best means best according to a human. And we matched again with the word-to-vector technique I just described, the average vector with all the other terms in the terminology to select a higher set of patterns to be then applied to the corpus. We performed some generalization of this automatic generalization on this pattern, such as the one which is described in the slide. So these were the 2 runs we submitted, and of course during the preparation of the runs we thought about a lot of ways of improving the results. Okay, the major point which worked for both approach is that the presence of a training set would allow a better tuning of thresholds. As I see, there are a lot of uses of thresholds in the system, but these are so far set, well, as a kind of a human intuition. You set it, you have a look, and you say it's better or it's not better. But with a gold standard, we could do, I think, better than this. Then for a grammar-based approach, the idea that we want to experiment is to use the training set, even a small one, to induce rule by using approaches which are used in the relation extraction domain and in knowledge graph completion domain. In particular, we plan to use NBURL, which is an open source system, and we already used it, experimented with it in the context of the TACRED relation extraction evaluation. For the second approach, as we said, I think it will be crucial to perform threshold tuning, but also trying different proximity algorithms. That is, leaving the cosine distance of the average seeds or whatever, and maybe testing different approaches to see if the results improves. In general, these are point of discussion, as was thought for behaviors could be interesting to think about something which is okay, name identity relation oriented, but maybe a little bit with relation. Because it might be interesting, besides targeting wear mask, but also to see who wear mask or where the mask is weared, or all this kind of more relational knowledge. That's just an idea. The other one was, but it's really because we have the tendency to prefer it, is why not thinking about a creation of a social network corpus. I mean, corpus about social corpus about COVID, and social networks are available out there. I mean, they are almost all tweet, but we could provide, for instance, something from forums or other source, and well, it could be an idea to see what really happens in this kind of on this kind of media with this kind of communication. Okay, thank you very much.